Hi, this is Srikanth, Assistant Professor of Data Science Department. In this session, I am going to cover Travelling Salesman Problem. The name itself says Travelling Salesman. The salesman wants to start from his home and he has to visit all the cities, and after visiting all the cities and he has to reach the hometown. And after getting this particular topic, we can able to apply optimization techniques to find initial basic feasible solutions and move towards optimality in transportation problem, which also includes unbalanced and maximization cases. So the traveling salesman problem, here we need to consider how a postman delivers the post to the addressee. So he arranges all the letters in an order and start from the post office and goes from address to address and finally back to his post office. Initially he is going to start from the post office and he is going to move to from one addressee to another address and finally back to his post office. And if he doesn't arrange the post in an order, he may have to travel a long distance to clear all the posts. He has to arrange in a particular order in a way how he is going to. Similarly, a traveling salesman has to plan his visits, either postman or traveling salesman. Whenever we want to visit several cities or several places, we have to plan accordingly which city we need to visit first or which place we need to visit first. Now let us say he starts from his head office and go around the branch offices and come back to his head office. Like this, how a postman and how a traveling a salesman has to move from one point to and visit all the points, all the places and come back to its original place. And while traveling, he will not visit the branch already visited. Once when we are traveling, he will not visit the branch which is already visited because he has to complete all the works in that particular branch, and he will not come back until he visits all the branches. He should not come back until he visits all the branches. There are different types of traveling salesman problems. One is cyclic problem. In this, he starts from his headquarters and after visiting all branches, he will be back to his headquarters. There are several problems in the traveling salesman, but here we are discussing a cyclic problem. In the cyclic problem, one has to start from his place and he has to visit all the places whatever he want to visit. After visiting, again he has to come back to the own place. That is nothing but a cyclic problem. And the second one is acyclic problem. In this case, a traveling salesman leaves his headquarters and visiting the intermediate branches, finally reaches the last branch and stays there. In some situations, a traveling salesman which is going to leave the headquarters and visit all the intermediate branches, finally reaches the last branch and stays there. And the first type of the problem is solved by Hungarian method or assignment technique. The second one is solved by dynamic programming method. So first method, cyclic problem, can be solved by the Hungarian method or assignment technique. And the second one, which is going to be solved by using dynamic programming method. So points to note: the traveling salesman problem, where we sequence the cities or branches he has to visit, is a sequencing problem. When there is a sequence of the cities or branches he has to visit, then that particular problem is called sequential problem, sequencing problem. But the solution is got by assignment technique. And hence basically the traveling salesman problem is a sequencing problem. The objective is to minimize the total distance covered. Here, traveling salesman problem is a sequencing problem. So, we need to minimize the total distance traveled. And the mathematical statement of the problem is decide variable xij which is equals to 1 or 0 for all values of I and j. So as to summation of z is equals to summation of I is equals to 1 to n and summation of j is equals to 1 to n Cij for all I and j which is equals to 1 to n, which are subject to summation of j is equals to 1 to n xij which is equals to 1 for all I is equals to 1 to n depart from a city once only, and summation of I is equals to 1 to n xij is equals to 1 for j is equals to 1 to n arrive at a city once only. These are the two constraints which we need to consider. These are the this is our objective function. These are the two constraints, which is depart from a city once only, arrive at a city once only. And this is indeed statement of a assignment problem which may give to our more disconnected cycles in optimum solution. So in the assignment problem which may give two or more disconnected cycles in optimum solution, this is not permitted because we need not to have disconnected cycles, we need to have a connected cycle because it is a cyclic problem. That is, salesman is not permitted to return to the origin of his tour before visiting all the cities in his itinerary. Okay, so the salesman is not allowed to return to the original place, origin of his tour before visiting all other cities in the list. And the mathematical formulation of above does not take care of this point. A restriction like xab plus xbc plus xca which is less than or equals to 2 will prevent subcycles of cities A, B, C and back to A. And it is sufficient to state at this stage that all subcycles can be ruled out by particular specifications of linear constraints. And this part, it is easy to see that a variable xij is equals to 1 has no meaning. And to exclude this from solution, we attribute very large cost to it, that is infinity or big M, which is very larger than of all the elements in the matrix. In our solutions, big M is used. And now let us consider the problem. A salesman stationed at city A has to decide his tour plan to visit B, C, D, E cities and back to city A in the order of his choice so that total distance traveled is minimum. No subtouring is permitted. He cannot travel from city A to city A itself. The distance between cities in kilometers is given below. Here is the city A to A, B to B and C to C, D to D and E to E is not allowed. That's why it is given with M, big M. And the remaining values A to B 16 kilometers, A to C 18 kilometers, A to D 13 kilometers, A to E 20 kilometers like this. Here B to A 21, B to C 16 and B to D 27, B to E 14. Like this for every from each and every city to the other cities the distance is given. Instead of big M, we can use infinity also or any element which is sufficiently larger than all elements in the matrix can be used. So here we are making the column wise operations. So here in this column we are having the least value is least value is 11. So after modifying these values, here we are going to take the least value and we are going to operate whatever the least value has to subtract from all the elements of the row So here 13 which is subtracted, so 35707 which we have got. In the same way all the rows are modified, and here this is the TOCM. Instead of big M, we can also use infinity or any element which is sufficiently larger than all the elements in the matrix, which can be used. And we can make only 4 assignments, hence modify the matrix. Smallest element in the uncovered cell is 3. Deduct this from all other uncovered cells and add this to the elements at the crossed cells, and do not alter elements in the cells covered by the line. So here we are going to subtract 3 which is not covered line. So when we subtract these 3, the table will become like this. And we can make only 4 assignments, hence once again modify the matrix, sequencing A to C and C to B, B to E and E to D and D to A, as there is a type. So here A to C and C to B and C to B to E also 0 we got, and E to D also we got. Whatever the zeros which we have got, that that sequence we need to follow. And how we need to follow is how in which line we have got first 0, that sequence we need to follow. Here the first one is the sequence is A to C we need to take, and C to B and B to E and E to D and D to A. This is the sequence. From it is moving, whatever the salesman which is moving from A to C and C to B and B to E and E to D and D to A, as there is a type. Now sequencing A to C, C to B and B to E and E to D and D to A, as there is a tie between the 0 cells, the problem has alternate solution. When there is a tie, the problem has alternate solutions. The total distance traveled by the salesman is, we are going to add what is the distance between A to C, that is 18, and C to B 14, and B to E 14, and E to D 11, and D to A 12. And the total distance is 69 kilometers. And A to C, C to B, B to E, E to D, D to A, the distance traveled is 69 kilometers. See that no city is visited twice by the salesman. We need to check that no city has to visit twice. That is the condition for this traveling salesman problem. These are the references I have considered for this traveling salesman problem, and these are the web references I have taken. And in this session I have discussed what is traveling salesman problem and how to solve this traveling salesman problem, and also with one example I have discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.